Students, welcome to the knowledge series. Today's discussion is on propositional logic. Now the propositional logic is basically a part of the fuzzy logic, and it talks about the truth values. The propositional logic, when we talk in terms of a fuzzy statement, it's basically a linguistic or a declarative statement, propositional logic. And the statement which may be either true, false, and based on the truth and false. And above the truth and false, there are additional things we add it, like very very true or fairly true. Such type of statement we try to put across and to find some logic. However, here we are going to discuss a propositional logic in terms of
which one is the machine learning problem? One small question.
So here, if you look across the statement, the propositional logic is a Boolean logic with a declarative statement. That is what I mean to say. Linguistic or declarative statement. True or false, but not truth. And that means it is not having a two things, half true or a half false, like that type of statement. Logic is a mathematical tool for constructing and manipulating a symbolic expressions in a computer language. So logic in terms of a zeros and one, we denote true or a false. That's how we define. A propositional logic is a representational language that makes assumption in terms of a proportional that are true or false. Representational language or a linguistic terms we consider. Propositional logic considers each statement as a proportions. For example, P, Q, R. These are nothing but propositional logic.
It may be because one session, 20 minutes, about 20 minutes, I was not getting it.
So, what we understand is a proportional is an idea or an opinion of something that can be having a definite answer, or it can be stated in a very clear way. So logical operation under the propositional logic. Let's take a first logical operation as a conjunction. So under the conjunction we defined P conjunction Q. So this is nothing but a intersection or a and. So when we define the P conjunction Q in terms of a truth table, P, Q and P conjunction Q, when these two are true, this is true. If there is a true and false, we consider it as a false. If it is a false and true, we consider it as a false. And if this is a false and false, then we consider it as false. That means in this case, all conditions of P and Q will be
no, sir, thank you.
True when both the P and Q is true. So, otherwise, we consider it as a false condition under this propositional.
The video, we need
it
voice
takes
recording.
considerations the truth values. That is under the consideration of a conjunction case. It will not take other statements. Like if you put a 1 1,
Are you uploading them on
0,
cloud, sir?
0,
Videos?
0 1,
Videos
0 0 0. So this is just like AND logic.
Videos will not directly send to you.
Now when we talk about the disjunctions, this is the R statements, P disjunction Q, or like a V state, how we represent P Q, P disjunction Q. So if this is true, true. If this is true and false, true. False and true, true. False, false, false. So in this case, it is the disjunction behave like a logical OR gate, and when we combine the truth value, if all are false, that is false.
Yeah, yesterday a lot of problem with the audio.
If it is a false exists, it does not make any difference. It will always be presented as a true. So any two propositions can be combined by the word or to form a compound proposition.
Okay, sir. Okay,
it's called disjunctions. So that is what we state in the case of a proposition logic. Now, next statement we will go for a negations. when we try to see a negation notation is like this way, and when we talk about P, its negation is represented in terms of a P, so that if it is a true, it is false. If it is a false, it is true. So that is the negation's representation. Or we can say that if this is P, the representation negation P is equal to 1 minus P, and that is the 1 minus, when I say 1 minus P is nothing but 1 minus truth value of the fuzzy. That is the truth value of the fuzzy. So that is known as the representation. Now conditional. Conditional is that P implies Q. If P, then Q. So if P implies Q, then we say that negation of P,
that whatever it is uploaded.
negation of
Cloud link I have been updating in
with
every
respect
chat
to the
almost
distinctions values
to 50
of,
times uploaded.
Q.
And
So
even in the
we take
WhatsApp
the,
group also we have shared.
negation
And
of
even in the mail
this
also it is
particular
been shared more than
statement, that is
some
a
3 to 4 times, sir.
May
May I know your name, sir?
Q,
I'll
or
directly
P
send you
or
SMS
Q.
to your
So if you take a truth value,
or else I'll
P,
just
Q,
send you
and P implies
WhatsApp
Q.
also
If this
directly.
is true, if this is true, then this is true.
189 people
If
I
this is
sent one
true,
mail
this is
that
false,
if you
then
have
it is
any
false. And if it is false and this is true, this is true. If it is false, true. So if false case is false, if both are false, then that is true. And if both are true, it is true. But except the case, if this is false and true, this is true. Otherwise, and in this case, if this is true and the Q is false and this is false. So that's why in this case, in either proposition is true, or if the first proposition is false,
that I am asking. No, sir.
proposition
at
is
the
false,
section only.
that
Not
produces
cloud
true. If
We
the
already
first
received
proposition
cloud
is
link
true
mail,
and the
sir.
second
Thank
proposition
you.
is false, then it
No
produces
problem, no
a
problem.
false.
No, I'm
So
telling
So
you
this is
another
what we
participant
see
is
in this
asking about
particular
cloud
case.
link. I'm
So
telling
this
you
is
then not
indicating
for
that
this one.
it implies
Okay,
the
sir. Okay,
negation
sir.
of
Okay.
this one.
Thank you.
So when
That
you
time
try to
only.
see the negation of
Yeah.
this particular case,
That is at
it
40
is
minutes
what we,
duration. You
how
told
we,
that
how
that
we
is
create,
activated at
we
2 to
create
3
P,
p.m. or
Q, negation of
what
Yes,
time
sir,
it
yes,
is
sir.
activated. That I am asking.
Before
negation
the
of
exam,
P is
you
what we have
I will
got
give the
here,
link in the
and
PPT. In the PPT,
this one
I will show the link.
with Q. So
You
if you
type
take
the
this one
link,
with
automatically will goes to the
that
Google
is,
form.
this
Then
one
you
is
see
or
the
with
questions one by
Q,
one.
you will find
Select the option.
false,
Sir.
true, true,
Yeah, sir.
false,
Thank you,
false,
sir.
false,
Thank you.
true,
That only,
true,
sir. I asked that only.
true,
Okay, sir.
and
Okay, thank you very much, sir. Thank you, sir.
and false, true, it is going
Okay,
to be.
sir.
So that is what
Sir,
we see in
I'll
this
listen this
particular case.
Okay, sir.
That is what we see here.
Thank you all. Wish you good luck.
In the case of the P implies Q.
Okay.
Now we see the by conditions. By condition means P with respect to P and Q. If there is a two proposition P and Q, then by condition represents the either way. So if this is P and this is Q, bidirection is that if this is true, then this is true. But if this is true and this is false, then it's false. If this is false, this is true, this is false. But both are false, then it is considered as true values. So that is known as the case with respect to the propositions under the condition of a biconditionals. So here, if both propositions are true, then the propositional logic is true. Else, it is false. That is what consider. But if both are false, proposition is false, then it is considered as true because both are having a false conditions. Now, here one thing you have to understand that in the fuzzy propositions, the statement can acquire a fuzzy in a truth values. So that is the very important thing is that with respect to the fuzzy logic. Now here fuzzy propositions I have put in terms of a statement stating in terms of a, like for example, Adarsh attend class. If Adarsh attend class, then Ardra attend class. So Adarsh attend class, then Ardra attend the class. That is indicating that this is P and this is Q. So that is a proposition statement. Now that's the Trishur is in Kerala. So Trishur is a subject, Kerala is a predicated. So that is what we talks in the form of a propositions under the under this particular statement. Now we will see further with respect to a concept on tautologies. Now, what exactly the tautology is? Tautology is one of the important components that we used to discuss in almost all the university exams, and that's how the students find this particular questions appears in almost all the university exams. Now, the tautology statement says that if the predicated logic in predicate logic, it is useful to consider a compound propositions that is true, irrespective of the truthful value of a individual simple propositions. Compound propositions with this property is known as a tautology. Now, tautology statement is a particular statement. It talks about that if a statement you are deriving, if everything is coming in the form of a true, then that particular statement is treated as a tautological statement. That means the logic is showing a truthful values. That means based on the given set, if a P is a set and you are getting the same P set after applying the proposition at the output, then we term that one as the condition or the logic is in the tautological conditions. So to understand this one, we will see the example, so that then we will just come back. Now here we have taken an example. P is equal to true, P and Q is defined true, 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 false, false, true, false, false. That is true, true, false, false, true, false, true, false. Under these conditions, we try to apply this particular logic in such a way to derive whether it is in a conjunction disjunction. So here we apply the conjunctions between the P and Q, and we got these values, and we again take a negation of this conjunction, so we got this value. Now if we try to after doing this one, we again apply P implies this one. So after negation, what we do, we give a conditional statement here. P implies you remember the P implies Q, so that is how this is a Q, entire value is treated as Q. So we apply that condition, and from the truth table we got this value. So because we know that under P the first case of the conjunction case is just like a AND logic, we got it, and whatever AND is there, it's negation. If you do opposite value, you got. And what is the conditional statement? Conditional statement says that if any conditional statement between this P and Q, P and this value, that means between these two things, if this is true and false, first one is true and second one is false, then that is false, and all other case will be true. That is what it is being shown over here. So this is one statement I am showing over here. Now based on this particular statement, now we will be going to a case to identify whether it is a tautology or not. So here how it has to put for solving, that is what I have shown over here. Let us see the tautological statement with respect to these questions. Now this is one question is state and prove that P implies Q, conjunctions Q implies R, implies P implies R is a tautology. This is what you have to find. So tautology condition means what? It is a compound conditions. So here we have written to prove this one. First of all, since there are how many variables are there? There are three propositions, P, Q, R, three variables. So automatically we will be based on these three propositions. 2 to the power of 3 means 8 conditions we will be able to get. So that's why true, 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 4 true, 4 false. Then 2 true, true, false, 2 true, 2 true, and true, false. So that's all. Then true, false, true, false, true, false, true, false. So that's one. We have written for 0, 0 to 1, 1, 1, 1 to 0, 0, 0. So the 8 possibilities. Now first we have written P implies Q. So we have found this logic. Then Q implies R. We have got this logic. then we create these particular conditions, that is P implies Q, negation conjunction of Q implies R. We created this truth table. Between these two truth table we got this one. Now for here what we have done is that we try to find that we have got this one, that is over here, and P implies R. We try to develop here, that is between P and R. So P implies R, we got it here. Now this implies this, that is the output. So between these and this we try to apply. So what we got, all are true. Can you see, all are true values? So when all are true values indicates what does it means. Here you see none of the logic it has come as a condition of a true false. True false nowhere is there. All are false false. So these conditions shows that all are true. So this is the final proposition output is true, and it is satisfy the tautological condition irrespective of the input. So any output is producing a true value, that is known as proposition. That is what being stated here, that it will reflects a true value. It is useful for a deductive reasoning, for proving the theory and theorems and making a deductive inference. So if a compound propositions can be expressed in the form of a tautology, the truth value of that compound proposition is known to be true. Now based on this tautology and based on the inference systems, we will talk about this modus ponens in the next discussions, because these are this particular thing logical expressions is used for the inference conditions, fuzzy inference conditions. So that time we will be seeing this one, is that what exactly it means. Now here if you see that A conjunctions and A implies B implies B. Under this case it implies B is the implications. If you are having A conjunctions, negation of A and its disjunctions of A conjunctions B implies B is a distributive. Like that every modern ponens condition is being stated here. Now finally we will be seeing one more point is of a discussion, is that consider a logic station P and Q, and use a logical law to implies this P conjunction Q, disjunction P conjunction negation of Q. Now this one you are going to apply and trying to find out how it is going to reflect, whether it is having a tautology or not. Now when we have this statement, applying the these are the different properties, just like we have a fuzzy set properties: commutative property, associative property, distributive, idempotency, identity, transitivity. So these type of involutions, all these properties what we see over here, this is also true for the these propositions. So here when we apply a distributive law, P conjunctions of Q, disjunctions R, if you represent, so it is a P conjunction Q, disjunction P conjunction R. That is what. Similarly, if you do it this one, we get this one back. But here in place of Q, in place of R, if you are putting a disjunction Q, you are getting the same thing back, because P conjunctions Q and disjunction R is same as P conjunction Q disjunction negation of Q, because in place of R we have used negation of Q. That is what. So if Q is true and this is false, and if Q is false, then negation of Q is true. So that is what it indicates. If this is true, then this one will become false, and if this is false, this is true. So as per the tautology, if a P conjunction of a tautology is P, this is as per that law it says. And P tautology of entire things, what is that? It is equal to P, because this satisfies the tautological conditions. You see here, Q conjunctions, negation of Q is a tautological conditions. So if this is tautology, so automatically this is going to be P. This is a statement, but actually if you represent in the proposition, it will be appearing like this one. Now here we are taken a two table, because there are how many propositions? There are three propositions, PQ, PQR, but if you see here, this is the given questions. So here there are two proposition is given. PQ, so you are having a logical operation 2 to the power 2, 4 possibly, true, 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 false, false, true, false, false. So we taken the negation Q, we written P conjunction Q, then we written what? P is this one, and conjunction of this one, these two, these two will give you this one. Then what we do? We have taken this one. Between these two, if we do a disjunction, we get this one. So if you try to see here, what is P? True, true, false, false. So here we get true, true, false, false. So it shows that the P is P conjunctions is a tautology in P. So this itself it shows that it's a tautological condition, and that shows the proportional output of the truth pool. So that is what it indicates. So P versus tautology. P conjunctions of the tautological case is also P. So that is what it indicates with respect to this one, and that is what we try to see here. If you try to see this one, this particular condition is this one. This is statement is this one. But what is this one? This is known as P conjunction of tautology. That is this is same as this, and we P conjunction tautology is what? It is P. That is what we have proved here. So with this we conclude here on the part of this propositions, and in the next series we will continue with the propositions further. Thank you.